When you examine the latest deep field images of the universe, you'll find tiny red shapes scattered and isolated among the massive galaxies. In early 2024, astronomers analyzed these dots and reached a consensus. They were looking at incredibly dense galaxies that were forming stars at rates our physical models couldn't explain. That distinct red color comes from redshift. As the universe expands, space grows, stretching out the light waves traveling through it. Measuring that stretched wave allows astronomers to calculate how long it has been traveling, dating these objects to the dawn of the universe. To capture those highly stretched infrared wavelengths, astronomers rely on the specialized mirrors and sensors of the James Webb Space Telescope. Identifying these objects would explain how the earliest structures in the universe actually began to assemble. The initial galaxy assumption broke down when new spectroscopic data arrived, showing that 70% of these red dots contain hydrogen gas moving at extreme velocities. That kind of velocity points to an accretion disk. Think of it like water spiraling inward down a drain, pulled by an immense gravitational force. As that material packs together, friction generates massive heat and light, proving a supermassive black hole is present. Finding these active gravitational engines just 600 million years after the Big Bang presents a problem. There hasn't been enough time for them to grow this large using traditional stellar growth models. The data suggests the dust is actually a veil for active, supermassive gravitational engines. This chart shows the unique spectrum emitted by these objects. The intensity drops to near zero in the ultraviolet section, then jumps vertically into the red wavelengths, creating a sharp V shape. Normal cosmic dust filters light gradually. It cannot physically create this sheer drop-off. To explain this bizarre light pattern, astronomers proposed a new model, the black hole star. Picture a highly compressed, spherical cloud of glowing hydrogen gas. It churns and swirls, completely enveloping and hiding the dark core inside. To an outside observer, this massive envelope looks exactly like a giant star, but its internal engine is driven entirely by gravity, rather than nuclear fusion. Standard supermassive black holes emit intense X-rays as they feed, yet almost all of these red dots appear completely silent to X-ray telescopes. That held true until astronomers combed through archival data from the Chandra Observatory and found a single red dot emitting a strong X-ray signal. Researchers hypothesized that this specific object represents a transitional phase in the object's life cycle. As the black hole consumes its envelope, the gas cloud thins. Small gaps appear, allowing trapped X-rays to escape. Because this cloud rotates, those X-ray beams sweep across our line of sight, causing the brightness to flicker. This transitional object provides the observable evidence needed to verify the black hole star theory. If the light from these dots comes from black holes rather than stars, it resolves a major astronomical tension. The early universe didn't miraculously overproduce stars at impossible rates. It also means the timeline for supermassive black hole formation begins much closer to the birth of the universe itself. This is still a working hypothesis, requiring future observations to either confirm the model or dismantle it. The speed of this intellectual evolution is striking, moving from the dusty galaxy assumption to the black hole star model in just 14 months. A moment of wonder. As we continue to stare into that ancient cosmic void, the very first scattered light